Hi everyone, this is Lauren Heisey, and thank you for coming back for another video from Leanademy. This video is going to concentrate on the measure phase. So if you remember, we're going along the DMAIC Roadmap, and this is the second part of that problem solving series. So in measure, we're going to take so that we define the problem and define. Now in measure, we're going to measure that problem. So we're going to use process mapping. We're going to understand why process mapping is the basis for the DMAIC problem solving. Variation, understanding what variation means and what measures truly how that customer is feeling, and process data, right? So the Six Sigma equation, the different types of data and how data helps us to understand how the process performs. So let's start with process mapping. If you remember back in the define phase, we used a very high level map, the SIPOC. So we'll start with this quote with a process meaning. This is from one of my favorite ones from Edward Deming. If you can't describe what you're doing as a process, you don't know what you're doing. So it's the basis for that problem solving approach because it gives us that graphical representation of the process. Some general points to take in here is that we want to map the customer's perspective, not internally to the organization, but really, you really want to understand how things happen for a customer. And we can Gemma walks, right? We walk the process. Gemma means go to the place where the process takes place. There are different process maps to provide different views of the process. There's a SIPOC that we use in the define phase, which is a high level. Next, we have up a value stream map. It kind of provides us that bird's eye view of the process. It's maybe just about a step down from the SIPOC, and it does have metrics behind it. And what that does, it connects the high level steps, systems, and customer together. And it displays cycle time, value added time, waste, and takt time. And then we get into the detail process map. So if you think of the value stream map, it's kind of like when you're looking at when you're using Waze or Google Maps, it shows you the map, how you're going to get from point A to point B. But then now if you start to think about the detail process map, that actually gets us into the turn by turn directions, right? So it's the detailed steps and decision points of the process. And it's a deep dive into each process step in that value stream. So what is a value stream map? This is just a very basic value stream map, but you can see it provides the flow, right? So at the lean tool, it provides a bird's eye view of the process from a customer's perspective. This is where we start to think about, we have cut the customer on the right, supplier on the left, and then you can see we have all the different data points that we have. We have all of the different flows that are happening. It just provides a visual guide of material, system, and steps to get a project or service to a customer. It displays cycle time, waste, so think about those lean waste, value added time, material flows, and any work in progress. It's used during the define measure phase to map the as is, right, current state value stream map. And we do use the value stream map within the improve phase after you go through the improve phase, you will walk out of the improve phase with a future state value stream map that will look different from your current state. Now let's get into a detailed process map. So a detailed process map takes a deeper dive from the SIPOC and VSM. So think about when we're just looking at the value stream map. This will be a process for one of those boxes, right? It shows a detailed picture of a specific part of the SIPOC or even the VSM. And it shows details from start to finish. So we look at where we have rework loops, we have decision areas. It provides a worker level view. So if you remember here where we had the SIPOC, right? We had suppliers, inputs, process, outputs, and customers. So when we start to talk about the Six Sigma equation, this is where we're starting to get into that. We look at the inputs, right? So the inputs is the measures or the X's or independent variables into the process. So this would be people, customers, a vendor, systems, technology, materials, customer orders, and environments. And then the outputs are the dependent variables, right? Anything that's an output out of that process that we're delivering to a customer, and that can be product, service, cycle time, quality, customer satisfaction, revenue, and cost savings. The SciPoc starts the construction of the sigma equation, or the what we call the y function of f equation. So one of the things that's great about Six Sigma is it helps us with problem solving. So when I was talking about the y is a function of the x's, right? It's a relationship between the x's and the y's, right? The inputs is the x's, the y's are the output. So the independent variables, those inputs into the process, and then we have our dependent variables, which are the y's, the output of the variables. So what we're trying to say, what all this is trying to say here is that when the x's are optimized, right? So when we say process optimized, we're really talking about the inputs as well. If the x's are optimized, we can control that y. So this is where we get into problem solving, because we're looking at cause and effect relationship, right? So if we have a lot of x's that are causing a problem, we're going to feel it with the y. And this helps us determine the right root causes, the right root causes, meaning it helps us understand where the most pain is being felt. So let's talk about this for a second. This is a little exercise that I just want everyone to kind of think about. So if you think about, consider establishing a YF equation for a simple everyday activity such as reducing a good cup of espresso. So the Y is our espresso. So if we start to think about it, X is here, right? What are the inputs that needed to develop a great cup of coffee? When we think about the Y, right, we are looking at espresso. So what makes a great cup of espresso? So when we start to think about it, we want good espresso coffee beans. We want the right temperature. We want a good espresso machine, and the right type of cup is very important. Pressing the ground espresso beans, and then of course, so if you express it in the YF function, you're basically going to say the espresso's the Y equals the F, which is all of our X's, is that good espresso coffee beans, temperature, the machine, the type of cup, the pressing the ground beans. It's that's basically what goes into the YFX function. So we can control the coffee beans, the temperature, the machine, the type of cup, and the grounding of the espresso beans. We should have a great cup of coffee. So when we start to think about our X's, right? So think about back to the coffee thing, or in any type of process, we're going to have all of these X's, and we're going to think about it in a funnel. Because what we're trying to do is get to the critical few X's that are causing the most pain. So if you think about it, so they always have the potential X's at the top. You can have, there have been projects that I've helped my students or that I've run. I probably would have had like 50 X's, but we can't go and solve every one of those. So we start to look at different ways to figure out the critical few X's, and that's what's at the bottom. So with the DMAIC problem solving framework, we think about it in a toolbox where we use brainstorming to identify the X's. Then we use also analytical methods and graphical analysis and statistics in the lean ways to identify what those X's are. So then what we start to do is we identify the critical few X's during the analyzed phase that are causing the most pain. So I always like everyone to think about the Pareto principle, whereas 80% of the problem is only caused by 20% of the X's. I'm going to say that again. 80% of the problem is only caused by 20% of the X's. It's just the way everything has always worked. And when we think about Lean Six Sigma and problems, like I said, we might have 50 X's or 50 potential root causes, but we get down to those critical few X's that are affecting that Y output. Variation. When we start to talk about variation, people sometimes get hung up on thinking, because we're still talking about the YFF function. This is where we start to use those X's and the Y's to measure variation. Variation, I want you to think about this in simple terms, that variation is what the customer is feeling. The customer feels a bad process, okay? So think about that variation as something that they feel. So variation leads to a flawed process. So we think about it's outside the customer's acceptable parameters. So variation can be variation within data can look like no two things within the process are the same. The process will vary from day to day. All measurements and counts will vary. So what we want to do is control the variation so we can control the outcomes, right? So if we can control those inputs, the X's, especially ones that are causing especially the ones that are causing 80% of the problem, if we can control that, then we can control how the customer will feel within the process. So remember, 80% of the variation is caused by 20% of the factors. If you think back to last page, right, we had all these X's. Well, 80% of the problem is only felt by 20% of the X's. Well, so we have different types of variation types. So we have special cause and common cause. When we think about special cause and cause, it happens at a specific time and place. It's temporary, local, it comes and goes. I tend to think of the special cause when I worked at AT&T, they used to see a spike in phone calls every day. And the spike in phone calls usually happened around like Mother's Day. Mother's Day, I think, was the highest spike throughout the entire year. But that was seasonal, so that was a special cause that they were able to determine. It does lack statistical control, but if you know that it's going to happen, you can plan for it. A common cause is always present, right? So it's something that's always there causing issues, and this could be multiple data into different systems, like manual inputs, manual data that's not standardized. So it's common to all locations, and it only contributes to a small effect of the variation, and it's usually in statistical control. One other thing we want to do within the measure phase too is we want to talk about measurement system analysis. We want to make sure that our data is accurate and free of errors, right? So it's a procedure, an analytic procedure to quantify variation. So it can be applied to any data. I'll get into continuous or discrete in a later slide. But it's the entire system, the entire data system should be evaluated in what is measured, right? So we're looking at the operator, a person, or different instruments, reference a standard that is used to calibrate the equipment, procedure. We look at the method used to perform the test, and equipment, devices used to measure the product. And then we start to look at environment, surroundings where the measures are performed. So let's talk about data a little bit. So data, if you think about data, we have continuous and discrete data. So think of continuous as measuring, discrete as counting. Some examples of discrete data, continuous data is going to be time, temperature, length, duration, speed, money. And then we start to talk about discrete. We think about dropped calls, number of defects, types of defects, pass or fail, locations, and number of customers. If I want you to walk away from anything from this, is that I want you to understand the different types of data that there is. But just to recap, a couple things to remember that it's very, very important to go through all these different DMAIC phases. So I'm going to stop here for now, and I hope you've enjoyed this lesson. If you would like to learn more about the DMAIC process, keep watching for more YouTube videos, and please follow me below.